talking about the spatial data model. Now, as you already know, this spatial data model is the backbone of GIS, and many people are trying to work on spatial data structures, spatial data objects, in order to have a better performance, better data retrieval, as well as better data storage. Now, coming to the history of the GIS, you already know that in 1960 this particular geographical information system came into existence by Canadian Geographical Information System. There were some technical problems related to data structures and all. And then in 1970, there was slight improvement in this particular field, and the concept of topology came into existence. And then in 1980, the spatial data modeling, data structures, all those things came into existence. And subsequently, after the establishment of this technology, they tried to use this technology in day-to-day decision-making process, like in government planning organizations, and that is the way they moved from what I should say is in a research mode, and then they tried to develop that system and made it operational to a various decision-making process. Now, then in 1990, there were a lot of changes. We moved from geographical information system to geographical information science, wherein we also discussed about the object orientation, how we can handle the large databases, moving from 3D GIS to temporal GIS. And then in 2000, we started talking about the modeling spatial decision support system with GIS. Now, if you see the present era, now if you, we have talked about data structures, we have seen how this technology is useful for decision making, but now the main objective of this technology is how we can make this technology can be useful to our distributed users. Now for that, we have a WebGIS which came into existence anyway in 2000. And in present scenario, this is we are moving towards the web services, wherein your whatever the data you have, it can be viewed by n number of people situated any part of the world. They can query, they can do any type of analysis by sitting on their own computer. So web services is one, and then distributed computing, then knowledge discovery and databases, spatial database management system, and data mining. Now, if you see all these concepts, there are certain linkage to the information technology. If you see, there is an exponential growth of GIS along with the information technology. So earlier the growth was not that much prominent, but after 2000, after it getting combined to the information technology, this growth has gone tremendous. So because of use to this technology for various purposes, and also the information technology. So this is the way it has evolved from the conventional system to a robust, dynamic, distributed system. Now, just brushing up the thing, what basically a GIS mean, as we already know that it is nothing but you can input your data, you can manage your data, you can store your data, as well as you can analyze and generate output. Now, if you see as a whole, it is like a relational database management system, any management system. It all provides data inputting capabilities, management, manipulation, analysis, as well as output. Now, here we have a georeference data, and those data you can have all those 4 different capabilities. So how it is different to relational database, because in relational database you are talking about the relations, you are talking about simple data, but here you are talking about a geographical information, geographical data. So there are a lot of overlap between GIS and a simple information system, but in this we are more concerned about the georeference data. Now, what does a GIS? GIS basically works with objects, their attribute, and the relationship among the objects, and how these objects are stored in database using geometric primitives like volume, area, line, polygons, their attributes, and how they are related to each other. Now, if you see, there are two characteristics of a geographical data. One is a spatial data, whereas you talks about feature orientation, shape, size, and non-spatial data, it means any information or any qualitative information you are attributing to a spatial data. So these are the two types of data which are supposed to be the characteristics of a spatial data. And then you can say that where is the spatial reference, attribute, spatial relationship, and temporal component. So it is nothing but where, what, how, and when. How these, if you talk about a particular object, where it is that object located, what is that object, how it is related to other objects, and when it is going to change. So these are all different things which are being addressed in the spatial data. Now, coming to the GIS data models, there are various terms being used in spatial data structures or spatial data types, like spatial data objects, spatial data structures, and spatial data models. Basically, if you see, spatial data objects is more towards the digital representation of the real world, wherein your basic data unit users can manipulate and analyze in a GIS database. And in that, we are more concerned about the geometric and the thematic properties of the representation. So spatial data objects are only meant to represent the real world and how you can manipulate and analyze. While the spatial data structures are more towards the methods, how you can organize your data, and basically we are emphasizing more on storage as well as performance. While the spatial data models are supposed to be the high-level data structures that focus on formalization of the concepts humans use to conceptualize space. So if you see all these spatial data objects, spatial data structures, spatial data models, they are all related to each other with a slight, very slight difference between all these different terms used. Now, if you see a spatial data model, basically, whenever you want to model a real world phenomena, you have to use a spatial data model because you have to organize your real world into a systematic file structure and then model it to a particular application. So this is the basic use of a spatial data model. Now, if you see the present scenario, we are having two approaches which are being used for a spatial data